This is a review of identifying the significant figures in a number. We're going to look at a bunch of examples, starting with 4,867. Numbers that are not zero are always significant, so this number has 4 sig figs. 56, same thing. This number has 2 sig figs. Numbers that are not zero are always significant. Next example, 60,104. This number, for this number, we look at the first non-zero digit, which is a 6, and we look at the last non-zero digit, which is a 4. And every digit in between also is significant. So this one has 5. This whole first and last and everything in the middle rule applies to a number that doesn't have a visible decimal point. Like in this case, there is a decimal point at the end of the 4, but it's not written into the problem. And when the decimal point is not shown, you find the first and last non-zero digit and count them and count everything in between them. Next example, 2,900. Here's another example of a number that doesn't have a visible decimal point. In that case, you find the first and the last non-zero digit and count everything in between. In this case, there's nothing in between. It's got 2 sig figs. These zeros on the end don't count. If there isn't a visible decimal point, you never count anything beyond the last non-zero digit. 40.2. When there is a visible decimal point, in this case, you look at the first non-zero digit, which is a 4, and you count everything after it, whether it's a 0 or not. This number's got 3 sig figs. Here's another one. 1, 2, 3, 4, 5, 6. 6 zeros and a 3. 0.0000003. Again, we have a visible decimal point, so we count the first non-zero digit and everything beyond it. In this example, there's nothing beyond it. There's just 1 sig fig. 0.7. Again, decimal point is showing. We count the first non-zero digit and everything beyond. Nothing beyond it in this case, so it's just 1 sig fig. 4.6 times 10 to the 19th. When we're working with exponential notation or scientific notation, the rules don't change. We ignore the magnitude, the 10 to the 19th part. We look at these numbers. When there's a visible decimal point, first non-zero digit, everything after. That's got 2 sig figs. Here's another one, 0.006. When there's a visible decimal point, first non-zero digit, and everything afterwards. This is 1 sig fig. 0.0605. We've got a visible decimal point, so we count the first non-zero digit and everything after. 3 sig figs. 60.500. Visible decimal point, we count the first non-zero digit and everything after. This has 5 sig figs. 60. Without a decimal point, we find the first and the last non-zero digit and count everything in the middle. This has only 1 non-zero digit, 1 sig fig.